All right, welcome back everybody. We are on 10.3 and this is going to be a chapter covering geometry review. So some of this you may know, some is going to be a review, some of it might be new to you. But anyways, let's go ahead and get started. So the first part, we're going to be talking about adding and subtracting polynomials. So A tells us to find the area of the shaded region. So the area of the outside, the large rectangle, the area of the small rectangle, and then the area of the shaded region. So we have to find all of these two things really, in order to find this third thing, the shaded region. All right, so to find, let me get a pen. So to find our area, we have area equals length times width. All right, so for the area of the large rectangle, we have 9x times 16x plus 5, and then we distribute this out. So 9x times 16x, remember when you multiply an x times an x, it becomes x squared. So we have 144 x squared, and then 9x times 5 is going to give us plus 45x. Right, so this is the area of your large rectangle. Right, then we can find the area of the small rectangle. So 4x times 7x minus 2. Right, so 4x times 7x, once again, x times x becomes x squared. So we have 28x squared. And then 4x times negative 2 gives us negative 8x. All right, so once we have the area of both the large and the small rectangle, to find the area of the shaded region, we're going to do large, the area of the large, minus the area of the small. Right? And it's important that you put these in parentheses or you will not change the signs the way that you're supposed to. Right? Minus goes in between, and then 28x squared minus 8x. Now, the reason that it's important to put these in parentheses is because this minus sign has to be distributed to everything behind it. So our first part is going to stay the same, 144x squared plus 45x. Then we're going to have minus 28x squared, but minus times that minus 8x becomes positive 8x. Okay, so that's what the parentheses are there for. Make sure you're changing the signs the way that they should. All right, so then we can just combine our like terms. So 144x squared and negative 28x squared. So 144 minus 28 is going to give us 116x squared. And then 45x plus 8x is 53x. Right, so the area of the shaded region. All right, let's look at B. So B says to find the perimeter of the figure. So hopefully we know that for the perimeter, we're just going to add all of our sides. All right, so the first part tells us to fill in the missing side lengths. Well, we know that rectangles are going to be equal on each side, right? So if this line is 2x, then this side is 2x. All right, and if this part going down is x, then this side is x. But we need to figure out what our bottom of this rectangle is, right? So we know that if this were a line right here, it would be equal to x. So we have x, x, and 2x, so 4x. So that means that our bottom is 4x. All right, so now literally all we have to do is add all of these sides. So we have 2x plus x plus x plus x, 2x plus x plus x plus x plus x plus 2x plus 2x plus 4x. All right, so then we just add this up. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14x. That's our perimeter. So the next part of the notes asks, where do formulas come from? Okay, so let's figure that out. So for the area of a rectangle, we just discussed this one. We have length times width. So area equals length times width. All right, and then when we're dealing with the area of a triangle, notice that we get two triangles if we split a rectangle diagonally, right? So this is our base and this is our height, right? So we can find our area of a triangle by 1/2 of the base times the height. This can also be rewritten if we consider b and h and 1, then that can all be in our numerator. So b times h over 2. So base times height divided by 2. Either one of these is correct and they will give you the same answer. They're the same thing. All right, then we've got the area of a trapezoid. All right, so we have b sub 1, b sub 2, and our height. Notice that this is a square and a triangle, right? Your trapezoid. So our area for a trapezoid is going to be 1/2 times the height times b sub 1 plus b sub 2, all in parentheses. But we can do a similar thing for the area of a trapezoid that we did for the area of a triangle and put all of this on top and put it all over 2. Once again, they're equivalent to each other. They will give you the same answer, and both are the correct form. Okay, you could do either way. All right, so the next part says formulas for 2-dimensional and 3-dimensional figures, okay? So 3-dimensional meaning it's got some depth to it, right? We're looking at, a sphere or a cube as opposed to a square. So get the units right, okay? This is important. So 1-dimensional measures have no width, okay? 2-dimensional figures are covered with square units, right? So this is going to be squared. And then 3-dimensional figures, so 3D figures, are filled with cubic units. So these are going to be cubed, right? So notice we have cubed, squared, and then nothing like that. All right, so the first one we're looking at is a circle. So we have our circumference, 2 pi r, which is our radius. We could also do circumference equals pi times the diameter. And then we have our area equals pi r squared. So this is our radius, okay? We can find the volume from length times width times height, okay? Length times width times height. And these formulas will be given to you on like state tests, but it's important that you're still aware of them and able to understand them, okay? So we have the volume of a cylinder, pi r squared, and then what's different about this one as opposed to the circle is we're multiplying it by a height, right? So now we've got that depth that we didn't have when we were dealing with just a circle. Right, and now we've got a sphere, right? So like a ball or something like that. This is always going to be 4/3, okay? This is just part of the formula. You just need to know that. Pi r cubed, right? And notice that it's cubed because this is a 3-dimensional figure. Right, so make sure that you can understand the difference between squared, cubed, and make sure that you're answering in the correct units. All right, so on to the second page, we're dealing with the Pythagorean theorem, okay? You may have heard of this before. This might be a review for you guys, but let's start by just labeling parts of the triangle. So let's make sure that we understand what we're looking at, okay? Well, a triangle is composed of 2 legs. So A and B are the legs. And then our diagonal that actually makes it the triangle, this is our hypotenuse. All right, and what is the theorem? This is the easiest one to remember. A squared plus B squared equals C squared. Easy enough, right? So it's important, we have this labeled over here as A and B, but A squared and B squared are going to be our smaller sides. And C squared is going to be our larger side, our hypotenuse. Example 1. Use the Pythagorean theorem to find the hypotenuse. All right, so we need to find our hypotenuse, right? We were given 28 feet and 45 feet. These are our A and B, right? If we labeled these A and B. So that's what we're going to be plugging in. And you just make these squared. That's literally all you do. So 28 squared plus 45 squared. Then we're going to use the correct units here, which was Z squared. Okay. Let me go ahead and pull up a calculator here. So we have 28 squared plus 45 squared. Let's do these separately. 28 squared gives us 784 plus 45 squared, which is 2025, equals Z squared. All right, so 784 plus 2025 is going to be 2,809 equals Z squared. Okay, now remember that in order to undo a squared exponent,
second lunch, orange, grab and go.
all right, so in order to undo this Z squared and make it just one Z, we have to take the square root. Remember, what you do to one side, you have to do to the other. So we take the square root on both sides. So we have the square root of 2,809, and it gives us 53. So 53 equals Z. So answer it correctly in the proper units, which we know we're dealing with feet. 53 feet. Okay. All right. Still using the Pythagorean theorem, but now we're going to be finding a leg of the triangle. So we were given our hypotenuse in one of the legs. And let's use the proper units. So we have T squared plus 7 squared equals 20 squared. All right, so let's go ahead and work these out. So 7 squared gives us 49. So we have T squared plus 49 equals 20 squared, 400. All right, and in this case, we're solving for T, right? So the first thing that we need to do is subtract 49. So 400 minus 49 is going to give us 351. And then once again, we have to get this T alone by taking the square root of both sides. Whatever you do to one side, you have to do to the other. I don't know what it's doing. Anyways, so let's take the square root of 351. And we get 18.734. So we'll leave that as 18.73. So T equals 18.73. And then answer in the correct units. Always make sure you add your units on to the end. All right, example 3, once again, using the Pythagorean theorem, it says prove that a triangle is a right angle. All right, so we know that a small leg squared plus a small leg squared equals a large hypotenuse squared. So basically, we just want to make sure when we know all three sides of a triangle, if you can prove this to be true, that means that there is a right triangle, okay? So let's go ahead and look at that. So if we had 10 squared plus 24 squared, we want that to be equal to 26 squared. All right, so 10 squared, 100, 24 squared, 576, and then 26 squared. I'm just going to go ahead and work all these out in advance. 676, okay? So we have 10 squared, 100, plus 24 squared was 576, equals 676. So then we just combine our like terms. So 100 plus 576 gives us 676. So you can see that 676 does equal 676. So this is great, which means this is a right triangle. Perfect. All right, let's go ahead and do B. So we should have 21 squared plus 20 squared equals 27 squared. All right, so let's go ahead and work all those out. So 21 squared, 441. 20 squared, 400. And then 27 squared, 729. Okay, so we have 441 plus 400 equals 729. All right, so what we actually have, combine those like terms, 841 equals 729, okay? Notice this is not true. This does not even out. So this is not a right triangle. All right, example 4 says using formulas, find the diameter, circumference, and the area of a circle. Okay, so for the diameter, this is 2 times our radius. I'm just going to go ahead and write these formulas out. Our circumference, C equals 2 pi r, or C equals pi diameter times diameter. Area equals pi r squared. Okay, so let's go ahead and work these out now. So diameter is 2 times our radius. Our radius is 11. So 2 times 11. All right, and notice we're dealing in meters, so we're going to have 22 meters. Right, our circumference, we have our radius, right? We don't have our diameter, so that's what we're going to use. We're going to use the 2 pi r. So we have 2 pi times our radius of 11. Okay, and you can plug this into your calculator. 2 pi times 11. And we get 69, we'll round to 0.12. All right, and the last one is on area. Okay, so we have pi r squared. So pi times our radius, which was 11 squared. I don't mean to keep doing that. So So pi times 11 squared, 380.13. Okay, now this is the one where it's important to understand area is going to be squared, right? This was in square units. So our area equals 380.13 meters squared, okay? That's why we went over that first thing on the front page. All right, let's look at example 5. What is the height of a triangle that has a base of 8 inches and an area of 28 inches squared? Okay, so we know that the area of a triangle is equivalent to 1/2 base times height. So if we know that the area is 28 inches squared and that it's got a base of 8 inches, we can use this formula to plug in and solve for our height. So our area is 28 equals 1/2, that part doesn't change, times our base, which we know is 8, times height, which we're solving for. So now we just need to solve for h. So first things first, 1/2 of 8 is 4. Right, half of 8 is 4, so 4h. And then we just need to divide by 4. So 28 divided by 4 gives us 7. So the answer is 7 inches. All right, so we just have a little bit more of it on the back now, and this is example 6. So it tells us to use the Pythagorean theorem to find the length of each side of the triangle. So notice that we have 2x minus 3 instead of a single number for our hypotenuse. We also have a variable x for one of our legs, okay? But we're still going to treat this the same way. So we have 3 squared plus x squared equals 2x minus 3 squared. All right, and then we're just going to go ahead and work this out. So note it, before I go over these two, let's talk about the fact that 2x minus 3 squared is something that needs to be FOILed out. So this is 2x minus 3 times 2x minus 3. All right? So 3 squared gives us 9. X squared gives us x squared, stays the same. And then we FOIL this out. So 2x times 2x gives us 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x, negative 6x. And negative 3 times negative 3 gives us positive 9. All right, so we're going to go ahead and combine our like terms. Oh, that's not what I meant to write. So negative 6x and negative 6x is negative 12x. All right, so the first thing that we're going to do, we can subtract this x squared from each side. So 4x squared minus x squared gives us 3x squared. And then we're going to set this equal to 0 by also subtracting 9 from both sides. So we have 0 equals 3x squared minus 12x. All right, and then this is where we have this 3x squared minus 12x. So we can go ahead and factor this out, and we're going to have 3x times x minus 4. All right, so we're solving for our zeros. So 3x equals 0, and then x minus 4 equals 0. Okay, so 3x equals 0 is going to be, you divide by 3, so x equals 0. But we know that sides cannot be 0, right? We know that this cannot be equal to 0. So we can go ahead and eliminate that one. So x minus 4 means that x equals the opposite, which is positive 4. So that one works. Our side has to be the positive number out of our zeros. Okay, so now that we know the value for x, all we have to do is plug that in and solve. So 2 times 4 minus 3. Oh, didn't mean to put parentheses there. So 12 minus 3. Oh my gosh, I'm all over the place. 8 minus 3 is going to give us 5. And then last but not least, we have example 7. Use the formula for finding the area of a triangle to solve for x, and then find the length of each leg of the triangle and the hypotenuse.